Hello, everybody.
Hello.
Good morning.
Good morning. Hello. Professor Oswarik. Hello. Hello.
Yes.
Oh,
Dr. Kameya. Good morning.
good morning.
If I understand correctly, it's very early morning for you. 1 a.m. in Japan. Yes.
Japan is midnight.
Midnight. Okay.
Yeah.
Midnight. I see. It's a
Mm.
very late meeting for you. Okay. Perhaps we should get started. First of all, let me apologize for the problems that we had last week. Partly it was my fault because I didn't realize what the implications would be if I was not available for hosting the meeting. So when Jesus was disconnected from the communications, he was blocked from returning to the meeting because he wasn't able to be admitted to our session. So for that reason, I've eliminated that function, that waiting room function, since so far our experience is that we haven't had any real need for that level of security, and it's only getting in the way. So I think for now, if we do need it at some point in the future, we could resolve it. But at the way the meeting parameters are set right now, it allows anyone with the passcode, the meeting passcode, to join the meeting. And in fact, they can join at any time to the meeting. And they can join even when the host isn't present. Right? So the only difference is that if the meeting doesn't have a host, then there's no way of doing administrative functions like eliminating someone from the meeting or something of that sort. But so I think for now we can use this approach because it's much more flexible. And also, if the meeting should start, if someone's delayed and so forth, the meeting recording will start with the first person who enters the meeting, apparently. So that would be convenient. And so I just will also, for longer term, I'll just edit out any initial part that's not relevant to our meeting. What else? Oh yes, and I just wanted to, before we get started with Jesus' presentation, which is now our third attempt to do that. Well, I guess the first attempt was just an introduction, and the second attempt resulted in only about 20 minutes of the presentation. So I wanted to leave most of the time today for that, so that we can at least complete that presentation and have some time for discussion. But just before we do that, I wanted to take a look at the a short agenda that I did send out. You might notice that, let me just, perhaps I can just share this in a moment, just so you can see what I'm reading. Yes. So I was just going through the brief agenda. I did want to note that the recordings of their two previous meetings are available now. The way this works is that the recordings are made to the Zoom cloud, but I don't have very much storage there for meetings, only for about 3 hours worth of meetings. And so the meetings are automatically transferred to Google Drive account, where I'm able to access them long term and manage that storage more easily. So initially, the meeting will be available for about 5 days for download directly from the Zoom cloud. And then after that, they will be available, at least some number of the previous meetings, maybe not all of the meetings, but perhaps as many as 10 previous meetings will be collected and available on Google Drive, and so I've given here the links for the first 2 meetings on Google Drive. What else did I want to say? Yeah, so in the last meeting, I very quickly went over some proposals. That is to make the seminar a little longer, an hour and a half. And the other part of that proposal was to make it once a week instead of every 2 weeks. So we do have a few presentations coming up, and so I think as long as that's acceptable to everyone here, I think at least for the time being, we should continue to meet once per week. I know there was a possibility of another presentation by Dr. Sobchak. I think he mentioned briefly in an email that he might speak about relativity from the approach of Dr. Heston is. I think that fits nicely with the presentation that I was hoping to give. So what else? Oh yes, I just wanted also to fix our agreement that the start time for the meeting is 1600 UTC. That means that when you have a local time change due to daylight savings or whatever, that means the meeting time will change for you. So in the past, we had it scheduled according to Mexico City time. So everybody else would adjust when Mexico City adjusted. But now if we fix it as 1600, then everyone, including Mexico, has to make an adjustment when the time changes locally. So I hope that's clear. It gets a bit complicated. For example, in Japan, it's 1 day ahead, or at least it is now, of what we call it a Wednesday meeting, but in Japan it actually is more like a Thursday meeting. In any case, so just so that's clear. And please speak up if you object to anything I've written here, or want me to elaborate, or to leave even to leave it out. Just let me know. So the current speaker is going to be Dr. Cruz, and he's continuing his presentation from last week. The next speaker in sequence here would be Dr. Rodrigo Santilli, and that would be scheduled for next week, October 6th. Still tentatively, Gregory Kotzan from Poland, who I was hoping he'd be here today, but he doesn't seem to be. I can get confirmation, but he initially proposed to give a presentation on relativity theory. So I've scheduled that in 2 weeks' time. He has a poster in Polish, which will be the basis of his talk, and that's available on the group chat channel right now, and we'll talk about that later if you need access to that. But he said he'd be preparing an English version of that, so when that's available, I'll make sure that you can get a copy. So I've scheduled my own presentation for October 20th. That's in 3 weeks, and that will be specifically sort of a follow-on of the presentation that I gave at GOL. So we can do that. At least that's the schedule as I've set so far, and no one objected when I mentioned last week. So I thought, well, this time I'll say this is the schedule, and if you have objection, just let me know. And I'd be very happy to receive proposals for new presentations. So please feel free to add your name. And okay, So what else? And that's it. So so I'd like to introduce Dr. Guzman to continue his presentation. I don't know, Jesus, if you wanted to review what you presented last time quickly.
Okay.
That
Yes.
would probably be appropriate. Probably not everyone has had a chance to view the recording from last week, or not had enough time or motivation. But so if you'd like to give us a quick review and then carry on.
Okay. And thanks. Thanks a lot. Then I'm going to share my screen. Excuse me, I need a pen for activating this. Wait up. Okay, I have here now. Excuse me. I
No problem.
with me. Okay, then. Okay, I think you now can see the presentation. The title is Notes for an Axiomatic Formulation of the Interaction Concept. The title is because this is a work in progress that I was making with Professor Osiewicz in the past 3 years. Okay, here only some ideas about the presentation is that I want to start with one abstract the definition type, taking in the category of types like the principal reference for this development. And here is one outline of the presentation. First, excuse me.
Just a quick question. When you say category of types, is that a sort of well-accepted terminology? Is that when you? I think of types in the context of programming languages or something like that. But do you mean that more general?
Dr.
Yes.
Dr. Page, I can barely hear you. Could you please increase the volume? Thank you.
Yes, here is the term category of types that I am going to take like reference, and I am speaking starting with the idea of types in computer science, but in more general approach. Then the general approach is the category of types in the sense of category theory. Yes. Yes.
What would be an example of like a type as an object in a category?
Yes, for example, maybe I can. I think that after I can, or maybe I can go directly.
Yeah, if it's clear later in your presentation, there's no problem.
Okay, I go back with this after in my presentation. Yes.
Okay. Yeah.
Mm-hmm. Okay, then okay, this is the outline of the presentation. Then I start with one introduction. First, I wanted to speak about the formalization of Newton's Newton mechanics, and I like to express in the introduction the concept of measurement. And after I go to the principal subject of this presentation, that is the category of interaction systems. Then I define interactions and I make some presentation of the principal properties of this interaction defined in this way. Okay, this is the principal outline of the presentation. I wanted to start with some general considerations, because my starting point is that I think that every physical theory is established on the human experience on their natural environment. This is important because there are two principal ways of the development in science. One is thinking that everything is produced in our mind, and other is thinking that we only make registrations of the environment. I think that the answer to this dichotomy is that we are in one duality approach of the physical world, and then we take the experience from the environment, but we made abstractions in our mind that have one impact in the environment too. Then this is here put it in one comment of Ernest Mach, that says that the first step is the observation, and after of the observation, we conclude in one set of important facts that are incorporated to science. And then after of this, we made some process of deduction and formalization. Then I think that this idea is one important approach for this. Okay, and now I here only put some of the principal starting points of the theory of Newton about mechanics. And then I have to take your attention here in the methodological view. Newton starts with some principal definitions. And in these principal definitions, he used constantly some words. For example, he used the word measurement in almost all definitions. Here, for example, I can put this here, measure, and in other places. Then,
do you mind if I ask a question at this point?
Yes. If you want, go ahead, please.
Okay. Yeah. Well, this is something I've been thinking about for a while. Is that the difference between an observation and the presumption of a physical property, right? So if we say that magnitudes are only associated with observations or measurements, that makes the property that we're talking about somehow dependent on the measurement process, so that we would not speak of mass as being a property of some object, but rather being a result of some measurement. So are you emphasizing that Newton took the view that what we're interested in are measurements, and not so strongly interested in what we as you said earlier, like as a matter of deduction, we come up with an idea that objects have mass, for example, and that mass is a physical property, something real, and there might be different ways of measuring it. Some of these different ways of measuring it might even give different magnitudes. So I'm just, there was a movement in the early 1900s or late 1800s called the logical positivism, which insisted that the only thing relevant to physics is what we could measure. So is this what you're talking about here?
No, here I think that there is before some words that are important. He says quantity of matter. No? Quantity of matter is the measure of the same. Then this is associated with the concept of mass, because the concept of mass don't came from one idea in our mind, but came from the experience about the quantity of matter expressed in the interaction. This is my starting point. And the same is for quantity of motion. Quantity of motion is the measure of the same. I don't like too much after this affirmation here, because he here used some concepts not defined before.
Yeah.
No? Then I like it to start with some principal definitions in the most abstract way. This is the idea, because I like it to start with the abstract definition type. Because in the abstract definition type, you start defining the one one type, first establishing the name of the type, and after describing his quality using the one set of arguments.
Can I give just one example more? In relativity theory, it's very common to talk about inertial mass, for example, but the idea of inertial mass is almost mixing two of these fundamental magnitudes. Is that correct?
Yes. This is because inertial mass is related with motion, huh? And this is the meaning of that concept there. I think that after in the definition we can stress this. I'm go ahead here. And then I have some another important definition in the theory of Newton that are the concept of force. The concept of force, he again express like the one important thing here, change of state of the system. Then the concept of a state of the system is fundamental here. And then based on this concept of a state of the system, then we can express the concept of force. Then force is how the external body changes the state of one system. We used to think in an inverse way. We think that force is the action of one external body, and then we think that we made the measurement of that external body. But in fact, we made the measurement of the action of that body on the observer or the system of measurement that he uses. Then it is one important thing. And another important thing is here this. Newton speak about force and about centripetal force. He defined two kinds of force. Those kinds of force are different kinds of interaction. And then I think that it is important to see how the concept of interaction can make different attributes because they are saying different things about the systems. Then I take this different approach after in the presentation. And finally, I want to take your attention in here. He says, I do not define time, space, place, and motion because they are well known to all. I think that it is important because he starts with one idea of time, space, place, and motion, and thinks that the bodies are in this entorn, and then in this entorn is the process of interaction made. And here I want to change the approach and get time, space, place, and motion from interaction, because this is the unique things that we are defining here, like a starting point. Then, okay, I'm go here. Okay, I go back here with the idea of abstract data types. I am defining here in the computational viewpoint type definition are make it through their attributes. This is one important thing, because if we start with one definition, we need to say how are the attributes of that object that we are defining, and only that. And after, we need to define one representation of this object, that is expression with symbols and names, attributes. And after, we need to define the operations that can modify, create, destroy, select that attributes in these objects. Then we are going to use this after. Okay. Then I go here. Okay, and here one again, the idea of measurement like operational viewpoint. I am taking this idea from one article of Frank Sent in 1985. He says operational viewpoint, and I like to okay, here this is the idea. I think this is an important point. Measurements constitute the only link between reality and theory. Obviously, this relation is one reality theory is in two ways. And this is the concept behind the operational viewpoint.
Can I ask you, is this in particular contra our friend Zbigniew Olszewicz's point of view, right? Who often spoke about reality being a product of our imagination, independent of experiment. But
yes, I discussed too much with Professor Olszewicz's about this.
I can imagine.
because I think that the process is in this way. I think that if I use it before this kind of graphics, then he maybe gets accord with me, because it's the graphics used to represent one groupoid. Then I think that maybe in this way we perhaps may more near in our ideas.
So your identity arrows there, or your endomorphisms there on each side refer perhaps to a reality existing independent of people, and the other side or theory existing theory existing purely, like without only in its logical content, as opposed to being driven by measurement.
Yeah. But even it is needed in physics and in general in science. We need to use theory to act on the reality, and reality says to us something about that we incorporate in the theory. Then,
but for example, engineers like to work only on the left side of your diagram, right? They want to build things and make things and see how they work and so forth. But I shouldn't say that too quickly, of course, because engineers also use theory, but the emphasis is on reality, whereas physicists might work more on the right-hand side of your diagram, building theories like string theory and so forth, which have only a limited connection to measurement.
Yes, I agree with that.
Okay, yeah, I like your approach.
Okay, and then now I want to speak some about the operational viewpoint. Here is one more detailed definition, and then this needs the notion of equilibrium. Then here the idea is, when we made one measurement, the instrument or the sense that make that measurement is in equilibrium state. This need to get equilibrium state, and then we have one measurement. And then this is one important. And the other is that the operational viewpoint are based on a dual relationship between two types of variables. We can speak about two terminal measurement, and this can be transvariable and intervariable. Maybe one example we can use here to express that. A simple example. When we take in one circuit the state of this element, we need to do two things. One is taking one measurement between 2 points. And then we speak here about transvariable. And the other is to take here another measurement that needed to cut the system in one place. And here we speak about intervariable. Kirchhoff was the first that was using this terminology, and then he made this theory of the circuits in this way, using two kinds of equations that were related, these two kinds of variables, the transvariables and intervariables. We can say that this is the root of these two kinds of laws that he established for studying the state of one electrical circuit, for example. Okay, then finally with this we are at the end using some important concepts for express all these concepts. The concept of a state is related with scalar fields. Process is related with vectors and multi-vector forms. Wavefront or potential are related with the scalar forms and multiforms. Dynamics with derivation and measurement with the concept of evaluation using the lemma of Cartanis. Then this is the general idea of this. Then I'm going to continue. I think that for today I can go fast with this because our general definition of these subjects that we are going to use. Excuse me?
Lots of those slides you just went by are very interesting to me.
Okay.
But I'm not sure. I know you want to get through your presentation, so I don't want to point
too
much emphasis on the questions.
I'm going to use because these general elements that I am going to use have here some more detailed description. Then
when I see this, I see immediately the kind of discussion that I had with Zbigniew. It was very, especially your first slide where you listed the analogies like between say vector and process.
Okay.
And potential and covectors, right? Really, and all of these subjects are things that have come up in discussion with Zbigniew and also they seem to occur again. Like for example, Dr. Sobczak asked specifically in the first meeting about the role of covectors. You know, since the type of language that's associated with geometric algebra is only of the multi-vector sort of variety. So what you're doing here already starts with a more elaborate algebra in effect, right? With a richer algebra.
Yes. Yes, and here because all the concepts that I was identifying in the Newton definitions, I think that get one formal expression here in this. And of course, those ideas was used and developed by the Professor Osiewicz. No? Then the idea of take the scalar fields like the forms that we can describe the state of the of a system. He don't like too much the name the word system. He prefers to speak about the body or something like this. But sometimes I use the word system, and the state of this body or the state of the system are described with one scalar field. Then we can describe all the properties of the fields with the algebra of these scalar fields. The algebra built on this scalar field. No? Then this is one important idea, because then all the properties are elements of this scalar field.
Okay, yes.
Okay, then here I define then the word process using the for the description of the process multivector forms. Professor Osiewicz used to use only the word process related with vectors, with the concept of vectors. But I think that it is important to extend this concept in the idea of that there are different kind of process, and then this is the idea that we try to present to you when I speak about the definition of Newton about force. Then the concept of force is different when we speak only of the intensity of interaction, and is different when he speaks about the concept of centripetal force, because for the definition of the centripetal force, he needs more elements for describe this kind of interaction. And then, in fact, he is speaking there using no vector, but using covectors. No, excuse me, multivectors for that description. Bivectors, for example. The concepts of centripetal force are bivector. Then I think it is important point, because then it is in the concept of interaction we need for describing the process the concept of multivectors. Okay. And here is one representation we use in the last picture that I put it, but here is the representation of the vector associated with that with those elements of the scalar field. Okay. And here is the idea of wavefront or potential that are related with scalar forms or and multiforms. Then I think that the idea used with Professor Osiewicz for the representation, it was better, but I didn't get to put one representation. But because, for example, if I put here the representation of the field, he only used it to express excuse me.
To the level curves, right?
Yes, in this. And I think that it is better because he make to us one better idea of wavefront, wavefront. And this can be related with the concept of potential. And this is the importance of the scalar forms and multiforms, because here in the same way, we can speak about all the structure of the system, looking about how is the geometry and the form of the scalar form. Then I think that it is an important point, because this is that we use for make the description of the system in a general way.
Okay. I should mention that your time is passing, so I do want you to get close to at least the end of your presentation.
Okay, then how much time I have? Excuse me.
Well, it's approaching about 45 minutes so far of your talk, and you could have up to another half hour, I think, but without discussion. So.
Okay, but I have how much time more? Excuse me.
Let's say 20 minutes.
Okay, thanks. And then, okay, I go fast, and I think that I can go faster in these definitions, and maybe indeed. But now I wanted to arrive here. Huh? The definition of categorical interaction system, and here I start. I define the class of bodies in equilibrium state represented by phi. Here, phi is an object of this category of the category C phi. Then here I put it again the idea of Newton, because it is important that these objects are the states of equilibrium of the system. or in general, the states of the system. This is the objects of this category. This is the first point. And then if the system changes a state, then this go to another equilibrium state. Then I am using automorphisms for represented this process in the in this object. That I use the word body too to represent or to refer to this object. Then this is one important thing, because a body then is a equilibrium state system that, and then is described by the scalar field that are related with those properties of the system that are describing the equilibrium states. And then one automorphism is either taking the system in equilibrium state. Okay, and then I can speak about the action of one body in another body. The action is one morphism from one object to another object. Then this is a morphism that is related to these two objects. And here I am relating the concept of action with the concept of not the concept, excuse me, with the definition of amorphism between these two objects. Yeah? And okay, and then here we have the concept of interaction. The concept of interaction is a composition between the action of one object in another object, for example, phi 1 on phi 0, and the automorphism that is taken to object phi 0 in equilibrium again. This is the definition of interaction I have here. It is important to say that when one body is in equilibrium state, then we can speak about the identity here that here is represented by E0. Then we have here morphisms and the identity morphisms and the objects of the category. Then after of this, we can speak about the reaction of body phi 0 on phi 1. I go to the next. Here I am representing both kinds of interactions between these two bodies. Okay, and with that, it's important to say something about the associativity of the morphisms. Then this is expressed here in the associativity of the interaction that are expressed here, and this associativity can be expressed now in this way, that it is important to say that is here expressed first the interaction of phi 1 on phi naught, and phi naught is a passive body, and in the other relation, phi 1 is the acting body, and this body produce one interaction in phi naught. The associativity of morphisms here can permit to us to get these two descriptions that are physically different thus. Because in one of these, the body phi O are one passive body, and in the other the body phi naught is one active body. Then this is important in this definition. Okay, and after I have here some ideas about the extensive and intensive properties. Then I am taking like the reference body phi naught, and then in this body we have the action of body phi 1 and phi 2. Then the presence of these two bodies can be expressed in this way, and then here we are establishing one important results for the description of the property of the system, because here we are describing the properties of these systems formed between phi 1 and phi 2, and then we can express this property like one extensive property. Then here I think I have defined this. Then in terms of this relation, I have the body that is the product of the two bodies phi 1 and phi 2, and I have the interaction, the action of these two bodies that is represented like I note 1 plus 2, like the product of the interaction or the morphisms of the two bodies separates. Then
So this means that the category that you're talking about here is like a Cartesian category?
is a Cartesian category. Yes. Yes.
Okay.
And then I have here another concept that is the intensity of interaction. Here, by intensity of interaction is only the one measurement of the intensity of the action of object phi j on phi I. This is the concept here of intensity. Then with those, I have the definition of intensive property, intensive properties and extensive properties that can be used for describe the one system. Okay, and then okay, this is and then when we speak of a body phi A, we speak of one object of the category C5 described before. Okay. Then, and now one important thing is the concept of observer. No? Then an observer is a body interacting with the rest of the system. Observer is a body registering information from the interaction with other bodies. Then we can say that we are describing a system that is a set of bodies interaction between them. And then an observer is only one body of that system that is describing the rest of the system based on the chains of states that it is experiencing. Then, with this idea, then we can see here the concept of observer, because observer then and now is one active body in the systems that is only taking registration of the rest of the bodies in the systems. Then it is important because then we can speak about different bodies that are acting like observers, and then they are interchanging information about this process. Okay, yeah, and here maybe in one.
I like this. I like that picture very much. So phi 0 is like a human being, right? It's a very complicated system, but still a body, still an interacting body, like all other bodies, but it must necessarily have a very complicated set of states, which you have all these automorphisms here. You would have even many more, and relationships perhaps within the human being that's making perception of reality. but other bodies there have no, like their automorphisms are not really very relevant to this process.
I didn't understand this. The last.
Well, you show many automorphisms for phi 0, but phi 1, phi 2, phi n.
Okay.
We aren't worried too much about how the state of these bodies are changing.
Yes, but this interaction that is the action of all the rest of the bodies, I think that we can get in this way. In this way.
All of this is very abstract, but I think it's important to realize that you can apply it directly. Like, for example, that this idea of an observer, maybe a good example is a spacecraft, like being launched into the solar system, and the spacecraft is collecting data and changing its state, like even recording observations in its memory and so forth. But all it's doing is collecting information about the objects around it, like through some kind of interaction, like through taking photographs, through measuring electromagnetic fields, and so forth. Right?
In fact, I like it to see this in like exactly the idea of product in category theory, because we are here, for example, with the product, no? The product of C1, C2, no? And then we can here put the observer, but I am speaking here about the product of category. But okay, then I think here CPO, and the objects here Phi1 plus Phi2, and the morphisms here are EO1, EO2. But if we go back, then we can. I don't know if I am going to get clear in this picture. Because I need more space,
Yeah.
But here is Fig1, and then I have one projector here. Here a projector, and here I have one projector to the other. And then I need this morphism here. And I think that it is interesting to see in this way, because then the idea is that the different measurements that we made here are only abstraction of the effect on all the system. And then here we have only one projection of all the action of the system in this for describe this interaction, this particular interaction. Excuse me. Okay, I have here more some elementary examples, but I think that I don't we have not time for this, but maybe in another opportunity, the idea is that if we have one implementation in this way, then we can obtain different different description of the systems that we can okay, we can describe each of them separately, but those are in fact in this kind of relation. Okay, I'm sorry, I think I have no more time, and thank you very much.
Do you want to make one conclusion?
Okay, the conclusion is that here we can, when we define this kind, we use this kind of presentation, then with the we can understand better the idea of action, of interaction, and then after we can define, starting from this and selecting one kind of elements of this, what is time, what is space, and what is another properties of the system. Then it is important from this that the next step is to select one of these for make one description of all the system, and then we take one of these interaction for describe or relate this to time, and something more for relate this to the space.
Okay, well, I think that's really very good. I understand more clearly sort of where your direction. There is a question from Dr. Santilli.
Okay, please.
Thank you. I'm sorry. Very exciting lecture indeed. Thank you, Professor Cruz. I would like to express my full support to your point that the morphism has to be associative. Indeed, in the 80s, I was interested in what we call lifting algebraic structure into a non-associative form. But we encountered, I was working with the mathematician, Professor Myung, but we encountered very severe problems. For instance, we could not define the Poincaré-Birkhoff theorem with a non-associative product. And so therefore, we couldn't do the exponentiation, and we had all sorts of other. So this was, I published this negative result in a paper at Physical Review D, that essentially an enveloping algebra regarding physical application, the enveloping non-associative algebra do not appear to be suitable for replacing conventional associative. So I'm fully in agreement. However, I would like to move a question in the spirit of my conversation with Professor Ozievich, namely at the edge of knowledge. Okay. So the question is the following, that as I'm sure several of you know, that there is now a drive at CERN to try to establish experimentally what they call the fifth interaction. So this is something really fundamental in line with this type of. So the question which I asked myself by listening to your talk, how is there any possibility, even remote, of extracting from your talk any insight toward what this fifth interaction is or could be? And the tentative is not an answer, but the comment it seems to be the extraction of any specific answer is related not so much into your abstract formulation, because your formulation is abstract. Being abstract is the most general possible formulation that I know. When you speak about an associative algebra, you say in abstract terms. That's it. You are associative or non-associative. So the possible answer is related to the realization of your very nice abstract formulation of interaction, because of course in physics, in electrodynamics, we use quantum mechanics. We realize associative algebra with the product that we have learned in high school. 2 multiplied by 3 is equal to 6, and we know the law of the associativity. But there are other realizations of the axiom of associativity. That's where the concrete difference in explicit form of interaction may occur. This is also somewhat related to Newton's force, Newton's idea of interaction. It is my view that we at the edge of at the dawn of the third millennium, we have realized only part of the notion of interaction that were moving in Newton's mind, which I found identically reproduced, essentially reproduced in Luigi Lagrange, who lived in Torino, where I did my PhD. I studied his papers in Italian with their external forces in their analytic equations, those that have been used in the past century, the truncated equation, Lagrange equation, truncated Lagrange. Back to the point is this is notion connected to your point on a very nice formulation of axiomatic formulation of a potential interaction. This is as I'm sure you know, this is a subclass of the Newton force. I studied in details in my book on Springer-Verlag on 1978 by using the conditions of variational self-adjointness, which is a realization of your notion of potential of your axiom. However, Newton also included all sorts of all other conceivable interactions that are not derivable from a potential, such as resistive interaction, which incidentally have zero range. You see, a potential interaction is at a distance. Other interactions are instead structurally different. So they are, which is considered a positive aspect, not a negative aspect. Your axiomatic formulation of a potential interaction, because this is only part of the interaction in nature. If we look at a balloon moving in the atmosphere, that's that Giovanni Luigi Lagrange used to do used to write in his papers, that you see this balloon moves, but where is the force? Well, the force is the contact interaction. Or there is shoot a stone through the atmosphere, and the stone slows down. So then this is resistive interaction and so on. Those are all variationally non-self-adjoint. They are all contact interaction. They are structurally outside, this is my point, structurally outside conventional realization of the associative morphism that based on the high school type of product, 2 multiplied by 2 is equal to 6. Do you have any comment? So I have a question. Do you think there is any possibility of extracting from your beautiful presentation, of extracting any hint at what was the explicit structure of this fifth interaction might be, with the understanding, however, that may well be outside conventional realization of your abstract axioms?
Yes, maybe faster, but I'm going to share again. Okay. Here in this implementation, it is important because interaction is here.
Yes, yes, indeed.
And then you have here one split of that interaction.
Yes.
Then I think that you can decide to split in different ways here.
Yes, yes. That's the beauty of the axiom, the axiomatic formulation. That's the very beauty, offering this variety of possible realization. Yes, Professor Cruz, yes.
Yes. And then when you split in different ways, you get different kinds of properties of the system.
Yes.
I haven't no time here. If we split in this way, then we can define here. We can find here the laws of that property. Here is the physical law corresponding to that split that we made. And then for X, we have one similar expression, but in terms of multivectors, we have those, yes, here. Then we can express the physical law corresponding to the split of the interactions that we made. And then we can implement different kinds of splitting of this interaction, explore different kinds of splitting, and then we can get the properties of the system. This is the general idea that I have. I made some exercise, for example, for Newton mechanics and Hamilton mechanics too, and then we can find in this way the both terms related to the multiforms and multi-scalar forms and multi-vector forms related with this split of interaction. Then, okay, here is some, but of course it is needed to make more work about this.
Is there a possibility of extracting out of this realization the Newton resistive forces, which are not derivable from a potential? So this will open a completely new field in physics, if that's possible. Yeah.
Not from the potential, but I don't understand this because, for example, here in Newton mechanics, I proposed this scalar form. And with this scalar form, I can split this in this way. And then we get here one multivector and one scalar form that are describing the system.
Well, let me, maybe I could just elaborate a little bit to Dr. Santilli's point he was making, I think, that for me, when I think about associativity, I think about the idea that any interaction can be reduced to an interaction between pairs of bodies. Right? So that if we have associativity, then we have essentially equivalent of something like center of inertia or something like that, where we can describe the entire motion of the solar system in terms of only the motion between a planet and the sun, for example. But if we don't have associativity, then we have a more complicated situation. Then when we say that two things interact, with many things interact, we can no longer decompose it into pairs of interactions.
One of the problems are many others. Yes, yes.
Yeah. So for example, in quantum mechanics, there is a recognition that, at least in some cases, there are some interactions which are always interactions between three bodies. That you cannot describe the interaction between these bodies by simply dealing with the quantum mechanics of two bodies at a time. That you must describe the entanglement, for example, between the three objects as a separate physical property, something different than the entanglement between pairs of objects alone.
Indeed, yeah. Incidentally, this is a big issue that the CERN is investing $1 billion in trying to prove this fifth interaction. As you may know, that very quickly, only a few seconds, you know, there have been recent measurements at the Fermilab that there are deviations. They measure deviations from the prediction of quantum electrodynamics, the first time in history. Quantum electrodynamics, until those experiments have been proved to be exact in an unbelievable way. And Fermilab made the measurements for the muons. It turns out to be the anomalies from the prediction of quantum electrodynamics. So there is now a worldwide drive to try to salvage quantum electrodynamics. And the only way via the standard model, the only possible way, conceivable way, is to try to establish new interactions. Because they cannot, they've tired, the standard model are tired of conjecturing a plethora of new particles, so they don't want to, but that's another story. So, but back to this I would like to address in my lecture next week. I would like to address the issue that there is more than one realization in full of all the property of the axiomatic definition of an associative ring, of an associative morphism. That I would like, because in those different realizations of exactly the same action, I believe there is a hope of locating those interactions that cannot be derived from a potential. The fifth interaction, we already know, cannot be derived from a potential interaction. We already know there will be all sorts of inconsistency, incompatibility with existing quantum electrodynamics. So what is it? That's what I would like to try to answer in my question, as a complement to the beautiful lecture by Professor Cruz. Thank you. Thank you for the chance of expressing.
Okay.
Thank you.
I think we have to quit now. I mean, we're a little bit past our 1.5 hours, but I think this was a very good lecture, very stimulating, and I appreciate your persistence, Jesus, in getting this presentation to us, despite of the technical problems and delays and so forth. And I look forward to perhaps returning to some of the sort of foundational issues that you mentioned in your talk, say after we have some new presentations, Dr. Santilli next week. Perhaps these subjects will come up again. So I think.
Very interesting.
Anybody else have a comment? Any other comments?
Oh, I think it's been very interesting. I'm looking forward to Professor Santilli's talk, and a very, very interesting series of talks here.
Okay.
They're
Well,
really
see you all next week.
Really fundamental, indeed.
Then we'll see you all next week. And oh, sorry, Larissa.
If I can add something, I was a member of seminars where Professor Jesus Cruz was explaining his ideas with comments of Zbigniew Fozievich. It was marvelous time. We were taking about 6 of sessions about all these topics. And today I see the perfect presentation, which was just crystallizing during this time.
Yes.
Thanks to observation of Zbigniew Fozievich. He recognized immediately the category structures and all these operations. I would like to congratulate Jesus for his success today. Thank you very much to all of you to recognize his work, which I was seeing from the very beginning and those 2019. Thank you very much.
Thank you.
Thank
Thank you.
Okay,
Thank you.
so goodbye for now, and see you
Yes.
next week.
Yes.
Bye bye, everybody. Bye bye.
Bye.
Bye bye.
Gracias. Thank you.
Certamente. Bye bye. Bye bye.